So for the last several days, I've been struggling with some kind of bug that's made it a little bit difficult to talk, and I'm currently pumped up on quite a few different types of cold medications at the moment, and I have to admit, it's made me a little grumpy. 3 days ago, I really had no intention of making another video about Mars colonization, although I think a lot of content really should be made about this topic because, after all, it interests all of us, SpaceX fans or fans of any other launch provider, space science, etc. All of us are excited about the notion of colonizing the red planet. However, as I said, 3 days ago, I saw an interview with a man who is rapidly becoming the biggest enemy to the notion of Mars colonization, and that is Neil deGrasse Tyson. I saw this interview on CNN, and I have to confess, it really pissed me off even more than he usually does. He made the old tired comparison between Mars and Antarctica and how people are not lining up to build condos there. He talked about how expensive all of this is going to be. He talked about the fact that mankind is already on the red planet and has been for some time with his various rovers. And all during the conversation, he chuckled a bit, and so did the CNN interview, and they exchanged a few wry grins as well about this absurd concept of colonizing Mars, even though the CNN interviewer had about as much knowledge about colonizing Mars as the average Cocker Spaniel. And although it's easy to dismiss the opinions of some CNN news anchor, it's a lot more difficult to dismiss the opinions of this guy. He's very well known. People who have any interest in science whatsoever know who Neil deGrasse Tyson is, and he is also regarded with a great deal of respect, and he has a lot of credibility with the general public. And the more he says stuff like this, the more difficult it becomes for us to establish a self-sustaining civilization on Mars, which, to be frank, is possible with today's technology. And I'm tired of the comparisons with Antarctica. I'm tired of talking about how robots can do everything we need them to do. And frankly, I'm just sick of the whole damn thing. And I'm going to explain just how dead wrong Neil deGrasse Tyson is about Mars in just a moment. Now, I'd like to make one thing abundantly clear. I don't want to take anything away from the accomplishments of the Mars rovers. Curiosity, Spirit, and Perseverance, all of those rovers, all the way back actually to the original Viking landers, have accomplished a tremendous amount. However, it bears mentioning that since 1976, all of the decades that have passed since that first historic landing of Viking 1, we still don't know if there's life on the Martian surface. As a matter of fact, no lander, no robot has tested for the presence of life since Viking 1 and Viking 2. And the reason for this is complicated. There has to be a lot of different equipment, a lot of different samples that you need to introduce to the Martian regolith to definitively prove whether or not life is present. However, the experiments that the Viking landers carried out were very, very compelling. I've talked a lot about the label release experiment, which produced carbon dioxide, which only should have happened in the presence of organic matter. On top of that, once the soil was heated to 150 degrees centigrade, it stopped producing carbon dioxide. Then they decided to heat it it to a lesser degree, only 50 degrees centigrade, a temperature that would have had a negative impact on anything living in the regolith, but wouldn't have affected anything chemical, producing some sort of mysterious reaction that was producing this particular effect. And guess what? The production of carbon dioxide dropped by 60% when the nutrients were introduced. Every conceivable combination of tests were carried out with the label release experiment, including regolith that was underneath a rock. They moved a rock that had been there for hundreds of millions of years, no real geological processes to have moved it there, and then tested the regolith underneath it, which would have been shielded from the effects of cosmic rays. That too produced the same results. In addition to that, they also performed a pyrolytic release experiment that heated a sample of Mars soil, and organic residues started coming off of the regolith. This is an experiment that isn't talked about as much, but it was also positive. And then finally, on top of that, they exposed the regolith to water, and the regolith began producing oxygen, whereas it should have started producing CO2. This was a very strange effect, something that shouldn't happen in the presence of organic life, and was therefore dismissed as some sort of mysterious chemical reaction. However, we have since discovered a particular type of bacteria that would have produced this kind of effect, but I'll get to that a little bit later. The only thing that came up negative was the search for organic molecules. However, the equipment on the Viking landers was not particularly sensitive, and the subsequent rovers with much more sensitive equipment have detected organic molecules since that time. And there are other compelling discoveries, such as seasonal spikes in methane, which may have an organic cause, seasonal spikes in oxygen, which may have an organic cause. All of these things are very strong indicators of the presence of life on the Martian surface, in spite of what everybody talks about when it comes to radiation and that sort of thing, as if radiation would somehow destroy every bit of life, every trace of life on the surface of Mars, even though such life could have evolved many hundreds of millions of years ago when Mars was much more friendly to the presence of life and had a lot more protection from said radiation. I am convinced that life evolved in Mars' distant past and then adapted itself gradually as the atmosphere was slowly stripped away, and I believe this for a lot of legitimate reasons, not the least of which is the fact that there are types of bacteria on our own planet that could easily survive and thrive on the Martian surface. But let's move on. In addition to all of that, there are so many other things that rovers simply cannot do. They can't venture into a lava tube. They can't even dig a 1-meter hole. They also can't climb up a cliff. There are so many restrictions that rovers have in terms of their mobility, and I am convinced that the moment that astronauts arrive on the Martian surface, take a scoop of regolith and put it under an electron microscope, they are going to discover life. As a matter of fact, if the first manned mission to Mars does not discover life, I will delete my channel. So now that I've gotten your attention, let's talk about the whole Antarctica thing. This is Antarctica in the summertime in perhaps the nicest garden spot that you can find on the continent. It is nothing like Mars. Yes, it's about as cold as Mars. Well, it's actually not nearly as cold as Mars, but other than that, there are no resemblances whatsoever. The hazards on Mars are nothing like the hazards that you would encounter in Antarctica. And contrary to popular belief, ecotourism is surging to Antarctica. People are going there in droves compared to the way it used to be 30 years ago, because people are getting into exciting and adventurous types of tourism. I am confident that we could find at least a few hundred, if not 1,000 people who would be willing to establish a permanent presence on the red planet, and that's all you need in order to have a self-sustaining colony from a genetic diversity standpoint. But let's get back to Antarctica. Here are some of the dangers. Number one is dehydration. Antarctica is actually one of the driest places on the planet. And yes, Mars is dry too, but at the same time, you're going to be wearing an environmental suit on Mars, so that's really not a factor. And it's not practical to wear an environmental suit in Antarctica for the reasons that I'll describe here in just a moment. Hypothermia is another serious problem in Antarctica. Once again, not an issue in a place that you have an environmental suit. Frostbite, another serious problem in Antarctica. Once again, not an issue on Mars. All of these things can simply be dismissed with an environmental suit. Sunburn, that is a serious issue in Antarctica, especially snow blindness. The whole concept of the reflectivity of all the ice in Antarctica and the constant presence of the sun, well, that's a very serious danger, even during a snowstorm if the cloud cover is thin. And on top of that, there's trench foot. That is a really nasty thing. It's an infection like gangrene, and it happens because your feet tend to get wet a lot in Antarctica as ice and snow comes into contact with it, leaks into your boots, that sort of thing. And if your feet are constantly wet, that means that you can develop this bacteria, and it can be very hazardous to your feet and to the future of your flesh down there. Not a very pleasant thing, and once again, not something you run into on Mars. The danger of crevasses, just stumbling across something in the endless white of Antarctica and plunging to your death in one of those. That's something that doesn't happen on Mars either. And finally, Antarctica is the windiest continent on the planet. Winds can sometimes reach 200 miles per hour, and sustained wind speeds of 100 miles an hour are very frequent, which makes building habitats in this environment extremely difficult, and just venturing outside quite the adventure. And whiteouts are a very common threat as well. There could not be two more different environments than Antarctica and Mars. Mars has lots of hazards of its own, many things that could definitely kill you, but it's not the same as Antarctica. And here's one of many very compelling reasons that one would want to explore Mars: the Hydrates chaos. And I may have mispronounced that. I'm not great on these sorts of Latin and Greek pronunciations, but nevertheless, this is an amazing feature. It's simply called chaotic terrain, and it has no equivalent on Earth, and we really don't understand what causes it. The best explanation that we can come up with is sudden and enormous eruptions of groundwater from the Martian subsurface, and that is a very strange phenomena. It could have also been caused by some sort of volcanic activity, but regardless of the reasons, this bizarre maze of narrow valleys and high buttes and mesas, some of which are over a kilometer in height, are unlike anything else in the solar system and are unexplorable by robots. Let me say that again, unexplorable by robots. You simply can't put a robot down into chaotic terrain like this and expect it to survive. Only humans are going to be able to explore this bizarre region of the planet in the future. And as you can see here, the whole area is deeply depressed compared to the surrounding terrain. Another phenomena that we really can't describe. As a matter of fact, some parts of this region are up to 5 kilometers deeper than the surrounding terrain. I can scarcely imagine how amazing this region would look if I was standing at the top of that tall cliff running through the middle of this image. That would be unbelievable. That cliff, by the way, is at least 4 or 5 kilometers tall. Much, much taller than any cliff in the Grand Canyon. And by the way, this isn't the Valles Marineris. This is another separate feature on the surface of an amazing and unique planet that we absolutely have to explore in person. We can't leave this to robots, and we can't allow conservative thinking to prevent us from going there at least sometime in this century, and hopefully within my lifetime. And I can say with absolute confidence that our current technology will allow us to survive on this planet as easily as we can survive on the ISS. The cold of outer space is far more dangerous than the cold on Mars, and yes, Mars does have more of a radiation issue, but there are a variety of different types of habitats that I've described in a variety of other videos that will protect us from the radiation. There's Olympus Mons, by the way, the largest volcano in the solar system, and just the plateau that it sits on is higher than Mount Everest. That's right, just the platform that this massive volcano is seated on is taller than the tallest mountain on Earth. What an amazing sight that would be. And once again, here's the Valles Marineris, the largest canyon in the solar system, with cliff faces as much as 8 kilometers high, unbelievably deep. Far deeper than the Grand Canyon, which gets roughly 1.5 to 2 kilometers deep at the very most. Amazing geological features on the surface of this planet that would not be as difficult to get to as they would in Antarctica. You don't have to deal with 200-mile-an-hour winds on Mars because the atmosphere is so thin that the wind can barely even be detected. Yes, there are problems with dust storms and other dangers, and of course, any breach in your environmental suit would be a serious problem, but we faced those problems for over 2 decades on the ISS, and so far we haven't lost a single astronaut. If we're careful and we utilize the technology that we have at our disposal, I'm confident that we can accomplish the same results. Now, of course, there is one piece of technology that is absolutely required if we're going to successfully colonize Mars, and that is Starship. If we fail to get Starship operational and the whole orbital refueling scenario doesn't turn out to be efficient, then it's going to be a lot more difficult to get the necessary equipment, the necessary supplies, and most importantly, the necessary population all the way to Mars. Far, far more difficult, far more expensive. However, there seems to be every reason to believe, even though I speak negatively about this ship sometimes simply because I don't think it's going to be ready to go in a couple of months, but still, I am confident that it will work eventually, and I am also confident that it will be taking us to Mars, or at least an unmanned mission to Mars, by 2030 at the latest. And once we have this ship in service, it solves a whole lot of problems. 100 tons all the way to the Red Planet is a lot in terms of equipment, in terms of supplies, in terms of everything you need. Now, there's the galactic cosmic ray issue and solar radiation and interplanetary space. These are going to be significant problems. However, linked in the description is a rather detailed article describing the best ways that we can shield ourselves against intergalactic cosmic rays and also from solar radiation. As long as we make the journey in the space of about 6 months and we have protection of 10 grams per square centimeter, which is roughly what the stainless steel is going to provide anyway. We may need a little bit more on top of that. The amount of radiation that an astronaut will absorb on a 6-month journey there and a 6-month journey back will be well within the 1 Sievert maximum that an astronaut is allowed to endure before they need to retire. And by the way, a full 1 Sievert only represents a tiny increase in your chance of eventually developing cancer. It's not like being exposed to Chernobyl or anything like that. And it's also worth noting that by 2030, NASA intends to have a fully functional nuclear thermal engine, which will cut transit time to Mars down to 90 days instead of 6 months. This will reduce the amount of radiation absorbed, of course, by a further 50%, down to roughly 0.2 of a sievert overall for an entire journey. that's something that's well within the range of safety limits, even with the time on the Martian surface. Why is that the case? Well, because Martian habitats are going to be designed with a lot of radiation protection built in. Plus, as I've mentioned many times, the radiation on the surface of Mars is not nearly as deadly as has previously been depicted. If you spent an entire year unprotected at the bottom of the Valles Marineris, you would soak up about 1/10 of one Sievert, which means it would take you 10 years unprotected to build up to that magical 1 Sievert level. But of course, you would be protected from a habitat like this one, which is comprised of a dome made of 3D printed Martian regolith, and inside that dome is an inflatable habitat that provides further pressure protection for the astronauts. It's essentially a double-hulled system protecting the astronauts from pressure differential, radiation, and of course the cold. And the way this is deployed is very, very cool. Lots and lots of miniature robots that can serve a variety of different purposes. I love these little things. Check them out. They can be deployed as small as one-wheeled devices used to explore the Martian surface, or you can consolidate them into these diggers that will excavate the necessary area to place the habitat or perhaps do some mining. On top of that, you can also put these robots together to build rovers or to build vehicles of certain kinds, all sorts of applications for this little robots. I love the whole idea. A modular robot capable of carrying out a wide variety of tasks on the Martian surface. And obviously, this will be deployed on the surface of Mars well before the astronauts even arrive to make sure that the entire structure is in place before astronauts are even risked. And one thing we need to keep in mind is virtually everything we need for human survival is on the Martian surface already. Let me say that again. Everything we need for survival is already on Mars. Okay, I didn't say it exactly the same way, but as you can see there, the 3D printing of the Martian regolith to make a radiation shield. Here comes the astronauts, and then the robots form this new construction device, this very large platform that allows it to move the habitat into place. Once again, the habitat being an inflatable configuration, very similar to the types of inflatable habitats we've already designed. Sierra Space and Bigelow Aerospace, others have already designed this, and this, of course, will provide the necessary pressure and life support for the safety of the astronauts. It's completely modular, which means you can have small ones, big ones for various purposes. This one perhaps for an aeroponic or aquaponic system to grow our necessary produce. But once again, keep in mind there's lots and lots of water ice beneath the surface of Mars, far more than there is on the moon. And if you have water, you have what's necessary to produce virtually everything else you need for survival. You can produce atmosphere with water. You can, of course, produce drinking water. You can also produce the necessary water and moisture to grow plant life, which means you only need to bring seeds along with you. Of course, supplies for the initial few months until the seeds start to grow, but even aeroponics may not prove necessary in the long run. Even though there are perchlorates in the Martian regolith that would prevent anything from growing for the most part, or if it did grow, it might be poisonous, we have a variety of different types of bacteria here on Earth that eat perchlorates and produce oxygen as a byproduct, and that bacteria may already be on Mars. Remember when I said that when we introduced water into the Martian regolith, it produced oxygen? The very same thing would happen if we had enzymes from these perchlorate-eating bacteria in a bag of Martian regolith and added water. That strongly indicates to me that we already have perchlorate-eating bacteria naturally living on Mars. But once again, we'll never know that unless we go there in person. But this is an amazing design. Once again, a perfect base camp of operations, a perfect place to start out from to slowly build out a larger facility, a larger colony on the surface of the planet, and explore this amazing world that is so much more interesting than Antarctica, at least in my opinion. And by the way, each inflatable habitat has its own redundant life support system in case of a breach or some other type of accident in the future in order to protect the entire environment. It's a very good design. It's one of many, actually, that are out there, and I am convinced that at least one, or perhaps a combination of these designs, would end up giving us a very nice home on the surface of the red planet. But of course, all of this is going to cost money, lots of money, and even the most wealthy person on the planet, Elon Musk, even he might not be able to cover the bill for all of this. But then again, let's put the value of a permanent human presence on Mars that would guarantee the long-term survival of our civilization against the $2.3 trillion that we spent on a 20-year war in Afghanistan, a war that may have been justified for many reasons, a war in which many people made colossal sacrifices, but in the end, after 20 years and $2.3 trillion and many thousands of deaths, Afghanistan is once again in the hands of the same government that controlled it way back in 2001. My question is, if we're willing to spend that much money on something that had that dubious of a return, why not invest in Mars just as aggressively? So Neil deGrasse Tyson, I urge you to stop being such a naysayer about all of this stuff, and as far as the rest of you are concerned, smash that like, hit that subscribe, check the description for various ways to support my channel, and as always, stay angry about space!